Hi everyone, welcome to this video on load flow analysis. Okay, now in this video we shall see how load flow is performed using a fast decoupled method. Now what is fast decoupled method? It is an extension of decoupled load flow method, and decoupled load flow is itself the extension of NR method. So in the decoupled method, the NRLF model is decoupled into two matrices, and these two matrices are given here. This is the decoupled load flow model. So this is one equation and this is another equation. So this equation is used to find out the phase, the correction vector for the phase angle, and this equation is used to find out the correction vector of the voltage. Now further simplification of these two equations, they are achieved using some assumptions. So what is the motive here? This H submatrices is there and this L submatrix is there. They are tried to simplify. So what is the first characteristic used or assumption used here? The first is omitting the series resistance. We know that the transmission line will have a resistance. There will be R value resistance, but this is assumed 0, so that the impedance, it will have only reactance. Only reactance will be there. And when we assume there is no resistors, resistance is 0, there is only reactance, we assume that the admittance is having only susceptance, there is no conductance. So here the attempt is made to convert these H and L submatrices into susceptance matrix, what we call it as B. Okay, so this is one assumption is done. The second assumption is done, cos delta Ik equal to 1 and sin delta I equal to 0. So now suppose this is the transmission line we have, this is bus number 1 and bus number 2. Here is delta 1 and here it is delta 2. Let these are the phase angles. Now the difference is delta 1 minus delta 2. Now this difference, it is very less. It is almost equal to 0. So when it is 0, we can assume cos 0, it is equal to 1 and sin delta it will be 0. So this is fair assumption as far as the power system operation is concerned. There will not be much loss in the accuracy of the calculation, but it will simplify the calculation very much. Then the third option is omitting the shunt reactances. If there is any half line charge admittances of the transmission line, they are neglected. Moreover, if there is any fact devices like SVR, static var capacitor or other, then their reactances are assumed to be 0. So that further makes the simplification in the computation of this susceptance matrix. Further, there is omitting of phase shifting transformers. Now there will be a phase shift because of the three-phase transformers like star delta or delta star like that, and that phase shift which is occurred due to use of such three-phase transformers is neglected. And because of that, the decoupled model, I'm not showing any calculations here how that decoupled model is reduced to this model. I'm omitting that proof here, but simply I've written the direct equation that now H is converted to B matrix. Okay, the H matrix what we had, because of the above assumptions, it get converted to B matrix, where B is a susceptance matrix. What is susceptance matrix? Now we have Y bus matrix, and in this Y bus we have so many elements, and we have G plus JB. We have conductance and we have susceptance. Now this conductance we are neglecting because we are assumed resistance to be 0. So we will have only susceptance value. So this Y bus is converted into BY bus. B bus, that is susceptance matrix. Okay. And similarly, so we can prove that the decoupled load flow equations, they are converted to this form where B is the susceptance matrix, and this is called as fast decoupled load flow model, which we can use for the performing load flow. Now this method reduces the computational time substantially, but it will have more number of iterations, and overall we can say that it is that not be that faster as compared to NRLM or Newton-Raphson method. So in this video, we have seen how load flow is performed by fast decoupled method. I'm not presenting here the flow chart and all. We can adopt the same flow chart as I have given for Newton-Raphson method. Only we have to substitute, we have to make these calculations. So instead of using NRLF model, we have to use fast decoupled load flow model here. Okay, so in this video, up to this only. Thank you very much.